Math 20-1. So you're continuing your travels, and now you've done multiplying and dividing, and now we have to add and subtract. And these are the learner outcomes for adding and subtracting, rational expressions. Come on. So just like we talked about with fractions when we reviewed our work with grade 6 and 7, 8, 9 with adding and subtracting fractions, to add or subtract rational expressions, you've got to have the same denominator, the same kind of slices. Just as with fractions, we add or subtract them with the same denominator by combining the terms numerator and denominator. So if you look at it from an algebraic sense, then if you got the same denominator as you can see here, then you simply add the tops. But that's only if you have the same slices. But it sure makes a nice, easy question if you have 3/7 of a pizza and 2/7, and obviously you have 5/7 of a pizza. Same thing works with subtraction, that if you have the same type of slices, then you can simply subtract. It doesn't work at all if you do it right. If you have 3/4 of a pizza and you subtract 1/2 of a pizza, you certainly don't get 3 minus 1 is 2, and 4 minus 2 is 2. You certainly don't get one whole pizza because you never had a whole pizza to begin with. That just doesn't work. You can't do that, right? No way. Okay, does that work? So you need to make sure that we're following good math practice. So in the following question, we need to add the following or subtract the following. And as you can see, these are set up really nicely with the same denominator. So in the first one, go ahead and add the first two together. Clearly, I can just go 3 plus 1, and I end up with, oh, one thing we did forget to mention is non-permissible value. So even here, in this general sense, you can't have a denominator of 0. We can have a numerator 0, as we talked about, but we can't have a denominator 0. So in question A, we add the numerators, get 4 over x plus 2. That's the kind of slices we have. You complete the next one. I want you to really think about this subtraction and how that might apply. So as we subtract that, who are we subtracting? Well, it's really subtracting all of that numerator, so we end up with 3a plus 2 minus a plus 3 to give us an answer of 2a plus 5 divided by a minus 7. And what a wise young math student once said to me, Mr. K, because I'm always messing these up, is it okay if I always, like my junior high teacher told me, instead of having subtraction, I will always add the opposite? And I said yes. So really, that person was telling me, can't I do this every time? And over here, wouldn't it be okay instead of seeing subtraction right here, couldn't I just go add the opposite of the numerator? And I said, yes, you may. And that way, every question really becomes addition. So that's something that you can think about if that's the way you want to do it. And this is the other way, to just put it in brackets and then distribute it after. Either way, you need to, as you do your formative work, watch and see if you're stubbing your toe on questions like this. In the final step, you always need to look, can I simplify this fraction? Does it work out? So as we add these two together, I end up with this answer, and I take out a 2, and this isn't the final answer because this is really just equal to plain 2. As long as we don't have that that non-permissible value. That's a pretty cool question, right? So even though this is very algebraic, in the end, that answer is equivalent to 2. So it doesn't really matter what you put in for n, it'll always equal 2. What about in questions like this, right? Determine each sum or difference, your turn. Okay, so carry on your work. Pause this. Please don't just sit and copy. I want you to pause, and now it's your turn to give it a go. Okay, so you're back now. I'm assuming you did. You should have got an answer of 2 over x, non-permissible value. Obviously 3x over x minus 2. And lastly, 2x squared plus 2, but you remembered to look for simplifying if you can, and we end up with 2. And a reminder, okay, just in case you were thinking, oh, maybe I forgot to simplify here. Remember, I can only cancel common factors. So if somebody was about to do something silly like cancel this x with this, we can't do that because those are terms and not factors, right? So just a reminder. So it's obviously a lot nicer when somebody gives you the same kind of slices. It's a lot easier to add up fractions or rational expressions. But what if we have unlike denominators? To add or subtract with unlike, we have to make the denominator the same. And we talked about that when we did fractions. Finding the least common denominator, we factor each denominator and find the least common denominator. The lowest common denominator is the product of all the different factors from each denominator, with each factor raised to the greatest power they could. That's a lot of words. What we talked about was our little troll story. And if you remember that, and if you don't, I could tell you the story again. But the troll story about you shall not pass. So the lowest common denominator is where you're going on that journey and you want to carry the least number of pieces, but the troll is going to tell you that you must build me any of those denominators. And so you need to have enough pieces to build any denominator. And that's really what that question is saying. And if you have enough pieces to build any denominator, that's good. But you don't want to carry extra pieces because you want the lowest common denominator. So for example, if I look at question A, what are the pieces there? Well, these two pieces are totally different. I need to have an x and an x plus 6. They aren't, right? I need to, in order to make an x plus 6, you need x plus 6. So the lowest common denominator for that is x plus 6. When I look at the second one, what are the pieces that are there, right? It's popping up and showing you right off the bat, but the first thing you always do is factor. What pieces make up x squared minus 16? What factors? Well, the factors for x squared minus 16 are x minus 4x plus 4. The factors, comma, for x squared plus 8x plus 16 is an x plus 4 times an x plus 4. So what pieces do you need? Well, you need to have at least two x plus 4s because you need two of them to build this denominator, or that, in this case not denominator, but if you did, right, and you need to have an x plus 4 and an x minus 4 to build that denominator. So you need to have two x plus 4s and one x minus 4, and that would be the lowest common denominator there. Okay, your turn. Find the lowest common denominator for each pair of denominators. So the first thing you have to do is factor them. Okay, if you don't factor them, you can't see it. So if I factor them, I would have a 5 and x minus 3x plus 3. In this one, I would have a 4x plus 3x plus 3. So what's the smallest number of pieces that I need? Well, I need to have, right, I need to have a 5, I need to have a 4, I need to have two x plus 3s, and I still need x minus 3. But I don't need to have 3x plus 3s because I don't need to build both denominators at the same time. Having these pieces in my bag would allow me to build either one of those denominators. Okay? And in the second one, again, you can factor it out, and I'll do this slower. If you've done it, this is a 5, 1, 2, 3 x's. This, if I take out a 5 and an x, I'm left with 2x minus 3. So what pieces do I need? What is my lowest common denominator? Well, let's look and see. What's the smallest? Well, I need to have a 5. I'm going to have at least 3 x's to build that first denominator. And I need to have a 2x minus 3. Those are the pieces that I need to build this denominator. And that's what you've got. Now, we want to rewrite as an equivalent expression. So for some reason, somebody has asked us to say, well, I really want a denominator of 72y9. And you have to ask yourself what pieces had to be added to this to create that denominator. What pieces did you multiply by in order to get 72 and and 9y's instead of 9 and 5y's? Well, I must have multiplied by top and bottom by a factor, because an equivalent fraction, you can only multiply top and bottom by the same number. It's got to be the same value. So what's the numerator? It's got to be 24y to the fourth. Well, how did we get from w plus 5 to this? Well, you need to factor that first to see what it is. It's w plus 5, w minus 2, so who got multiplied to w plus 5 to create this? Well, obviously it's w minus 2. Now you can't just do it to the bottom, so you have to do it to the top as well. So I multiply w over w plus 5 by w minus 2 and w minus 2, and I get a numerator of w times w minus 2. So now we want to simplify, and we talked about at the very beginning, we want to create the same denominator. So what's the lowest common denominator for 4x and 6? What would the troll say in order for me to pass? What do I need to bring in order to build both of those denominators? Well, the lowest common denominator is 12x, and you might say, well, how do you know that? How do you know that it's 12x? Well, this is a 2, and an x, and this is a 2 and a 3. So the lowest common denominator is obviously going to be built by having at least two 2's, one 3, and one x. Obviously that makes 12x. Now what you need to do is make each of those into a fraction with 12x on the bottom. So what do I need to multiply top and bottom by for the first one? 3. The second one needs to be multiplied by 2x top and bottom. And I need you to write it like this. Okay? You need to multiply top and bottom. Taking shortcuts and doing something silly like saying I'll just multiply by 3 is illegal. Okay? You can't just multiply the top by 3. We know that we have to, see, we know that we have to multiply top and bottom by the same value. Okay? We carry on. Now we have the same denominator, and I can just add them, and I end up with 2x plus 9 over 12x. And x can't be 0. Oh, this is trickier. You got to factor first. What pieces make up this denominator? Okay, now we're jumping right to the lowest common number, but I don't want to do that. I want you to see it. What pieces make this up? Well, 10 would be 2, 5, and c, right? If I take out a 5c out of this, I would be left with I'd be left with c minus 2. So when I think about the lowest common denominator, my lowest common denominator is built by looking at what's the smallest number of pieces I need to bring for the troll. Well, I need to bring a 2 and a 5. I got to have two c's so I can build the first denominator, and I got to have that c minus 2. What does that make? Well, what it makes is what it said a minute ago when it flashed. It makes 10c squared and c minus 2. So now you ask yourself, well, what do I need to do to each denominator? What pieces are missing from each denominator? Well, clearly in the first one, I'm missing a c minus 2, top and bottom. What's missing in the second denominator? Well, a 2c. Now you've created a common denominator, and therefore you can add them up. They're both denominators of 10c squared c minus 2. I add those two together, and I end up with 4c squared plus 3c minus 6. Right? And we forgot that the non-permissive values are c cannot be equal to 0, and c cannot be equal to 2. Okay? Adding those two fractions up. Working our way up the ladder. Again, ooh, we got subtraction here. Don't forget that wise young math student. What are you going to do with that? Okay. But again, you can't add and subtract until you know the pieces the troll wants to bring. So we need to factor first. Once you've factored, whoa, I don't want that c. Now, what pieces do you need? What are the pieces that the troll is going to ask you to have? Well, you've got 2x plus 2's, and then an x minus 2 and an x plus 2. Clearly, the lowest common denominator is going to be an x plus 2, an x plus 2, and an x minus 2. That's the smallest number of pieces you need. Now look and create the denominators, create common denominators. So what's missing in the first one? Well, what's missing in the first one is an x minus 2, and you need to show this step. What's missing in the second one is x plus 2. The wise math student said to Mr. K, Mr. K, I'm not going to get tricked by this. I will always add the opposite so that I don't forget, because that is a toe stubber. So if I do that, I will remember that that negative gets distributed, and my final answer is x squared minus 7x minus 14. And my non-permissible values, which we won't forget, are x cannot be equal to minus 2 and plus 2. Okay? Ooh, looking scary. We're starting to bring into play adding and subtracting and division. So combining our operations, right? What are we going to do with this? Pause, think, and come back. So if you've already started your journey on your own, it's really awkward if you think of this and take away the numbers. It's really awkward to do things like this. 1 plus 2/3 bracket divided by 2 plus 4/5. If you remember when we did questions like this, the first thing we did was make improper fractions. We don't want to multiply by the reciprocal first, because that's not going to work very well. You really need to have an improper fraction first. So the way to start this question is not to start by multiplying by the reciprocal, but instead by creating a common denominator to bring these two things together, right? So the first thing we'll do, instead of thinking multiply by reciprocal, is bring that together. So if we bring it together under a common denominator, looks like that was just magic and it happened really quick, but we can start to take some shortcuts. There's a denominator of x right there. I need an x underneath here, so I multiply top and bottom by x, which just becomes 2 minus 4x. The denominator here is x, so I multiply top and bottom by x here, which just creates 2 plus 3x, right? So it's really easy with whole numbers to create a common denominator, right? Now you've got improper fractions, I guess you could say, and you can multiply by the reciprocal, which really turns out kind of handy. The x's blow up, and you're left with 2 minus 4x over 2 plus 3x, and x cannot be equal to 0. Your turn to complete the following. All right, away you go. Come back when you're done. Okay, folks, you've gone off and given it a go, so Mr. K is going to work through this one. So x times x minus 5 is this denominator. I can see that my lowest common denominator is going to be an x and an x minus 5. That's what I need. So I go off and I'm taking a few shortcuts here. My common denominator is x and x minus 5. So if I do that, what do I have to multiply top and bottom of this one? Well, this one was missing an x, top and bottom. This one is missing, this one's missing an x minus 5, top and bottom. This one is missing nothing, but I do remember that this is plus or minus 10. So when I go over here and say, well, what do I have? Well, I'm going to have 4x. I'm going to have minus 2x plus 10, and then back here, I've got minus 10. What does that all simplify down to? That simplifies down to which now becomes 2x all over x and x minus 5, but the x's cancel out, and you are left with 2 all over x minus 5, and x cannot be equal to 0 or 5. In the next one, we have to factor it, and in this one we factor and we get x minus x plus 4 and x minus x plus 4 and x minus 1, and in this one we get x plus 4 and x plus 3, so my lowest common denominator is x plus 4, x minus 1 and x plus 3. So then I look back up top and I add the opposite. I don't want to forget about that. And I look and see what piece is missing from each of those. And in the second one, it's missing. The second one is missing an x, an x minus 1. So I multiply top and bottom by x minus 1. And in the first one, it's missing, what is it missing? It's missing an x plus 3. So when I put that all together, I end up with, so I just finished it off, you guys. So as you can see in question B, you end up with a final answer of x times x minus 5x plus 1 all over a common denominator, and nothing blows up. A little disappointing. And in the last question, I'm just going to show you the answer, but again, you need to put a common denominator on these two and bring that together. And when you do, you get a final answer of, 3x minus 9 all over 3x plus 2. Please ask tomorrow if that question didn't go as well as you wanted to. All right? We'll see you tomorrow.